So this is the flight simulator, and it's really exciting because this is sort of the final milestone before we head off and do our manned test flying in our real aircraft. This isn't just a flight simulator, this is the result of a lot of hard work over the past years and hundreds of hours of test flying our prototype. We've collected all that data through numerous iterations, design changes, and we've pumped all that data that we've learned into this flight computer. This is actually the hardware we'll be using for the real aircraft as well. We've seamlessly combined our redundant flight control software, controlling the 8 electric motors, with our simple, traditional and safe 4-wing fixed-wing design, leaving the pilot with as small a workload as possible, enabling them to just enjoy the flying experience. Now enjoy this video where I'll be showing Jaap and teaching Jaap how to fly the Axe.
We are in the Axe by Skyfly. Not the real one, but the simulator. This simulator, which we can see from inside and out, is a good simulation of what you'll experience when you've bought your Axe. Today I'm with Mike Thompson, CEO of Skyfly. He's going to demonstrate all the ways you can fly your Axe and how easy it is. There's 3 controls: the stick, the rudder pedals and the throttle.
Yeah.
Mikey, talk us through all of these and what do they do?
So your main center stick is for roll and pitch, which is basically to make you go either up or down or left or roll right. You've got your pedals, which essentially turn you either left or right. So it's a very simple and traditional method of turning. And then you've got a throttle lever.
So Mikey, I'm surprised because the Axe can be both a vertical takeoff and landing vehicle, like a helicopter, and it can be an airplane. If it's got enough forward speed over the control surfaces, we literally have cables here that move the control surfaces just like any old traditional airplane.
Yes.
So isn't it difficult to combine vertical mode and normal flying mode?
Yeah, so you've got your torque tubes that run to both your elevator and ailerons, in very much in a traditional sense with a traditional aircraft. However, what we've got is dual encoders on each axis, which converts your mechanical control inputs into electrical inputs to the flight controller. This is important, so when you're hovering, your control surfaces are moving, like you can see on the screen now.
But they don't do anything because there is no airflow.
Exactly. So as soon as you get over 45 knots, your lifting surfaces become active, and then you're flying like a fixed wing. So if you look on the screen now, you can see as I'm moving the stick, the control surfaces are moving. The front canard wing is the elevator, and the rear one is the ailerons.
And your feet are the rudder.
And this is the rudder on my feet, yeah. So what I'm going to do is I'm going to slowly increase the power, which you'll see on the screen below. And as the power comes in, we haven't got the brakes on, so it will tend to move forward slightly.
And we're in the air. So you let go of the controls and it just stays in the same position.
Yeah, you're not
so
really
you've got
doing
time
much.
to think and look where you're landing.
Yeah,
that's handy.
So we could have a conversation. So yawing left, yawing right, just purely done by the pedals. And you can see that the rudder
very stable.
The rudder is moving as well.
Okay. So how do we get to forward flight from here?
So to go into forward flight, what I'm going to do, you'll see the stick is slightly back at the moment. I'm just going to get a bit of height up, and stick's gone into the neutral position. So now the airspeed's building up. So what happens?
40 miles an hour.
So above 40 miles an hour.
Cool.
And it gets to 60. So now the aircraft's flying fully manually on its control surfaces. So you are not using any of the stabilization from the flight controller at the moment because it's an aerodynamically stable aircraft.
So it switches automatically from drone mode into airplane mode?
Exactly.
Okay.
So we're just cruising along. This is the perfect cruise speed for the aircraft.
100 miles an hour?
100 miles an hour. So we don't have to do anything really. It's, as I said, it's aerodynamically stable.
And the big difference with an airplane or a helicopter even is we can land anywhere very quietly. So do you want to demonstrate that, Mikey? Just pick like a nice green field or sit it down on the road if there's no cars?
Sure. So what we want to do first is get the speed down. So using a combination of throttling back and back stick, we'll get the power off. So just holding back gently the stick until the airspeed decays away. So you've gone past the stall phase now. So
It's now fully a helicopter only.
Yeah, so
Yeah,
the
the wings do
stabilization is coming from the flight controller.
So we're doing lots of vertical takeoffs. Now, the experienced pilots that are watching this, that are used to aircraft, could you demonstrate a normal fixed wing takeoff and landing?
Of course I can.
For fixed wing pilots, you're doing normally 1,000 feet a minute or so. This thing is 3,000 feet a minute or more.
So back stick, keep the stick back so your nose lifts off.
Adding power, speed builds, 16 mph, and we're already off. So when does it start flying as a normal aircraft?
About 30 miles an hour, all your surfaces become active.
And how much runway is that?
Less than 50 meters, yeah.
Less than 50 meters. One of these green fields, just without power entirely.
Yeah, sure.
You're at 400 feet, doing 55 miles an hour.
So I'm going to get a bit of speed on.
70 miles an hour. So, yeah, we can put it down straight away, can't you?
Yeah. As I said earlier, I don't have brakes.
There is a Cessna standing there, taxiing on the hold, but let's ignore that. Mikey, thanks very much for the explanation.
No worries.
I can't wait to have one and just take off from my own home and not be in a traffic jam. Thanks, Mikey.
No worries. Cheers.
Less time, more joy, amazing views.